Hi there, this is Dr. Matthew J. Traum from Engineer Inc. and the Bellevue Middle School Edible Learning Lab. In today's video, I'm going to show you guys how to build another weather instrument. This one's a barometer, baro, which means pressure. That means that this instrument is measuring the barometric pressure, which is the pressure pushing down on us from the air in the atmosphere, and it actually will change quite significantly as the weather changes. As storm fronts move through, the local barometric pressure goes up and down quite a bit, and this instrument is sensitive enough to detect that. This is one in a series of videos that I'm making to show you guys how to put together an entire weather station, which includes a rain gauge, a barometer, a thermometer, and an anemometer. This is the second such video. The first one was the rain gauge, and I'm assuming that you guys have already built the rain gauge because, as you'll see in the next segment of this video, we're actually going to use a feature of the rain gauge to help us take our ambient pressure, our barometric pressure measurements, but we'll get to that in a moment. So first, let me show you how to put this thing together. So there are really just a couple of components here, and I'm assuming that you guys have got these laying around your house. So we're going to need a hot glue gun. We just need one little dab of hot glue. This is a mason jar for canning. This is just a balloon. This is a rubber band. This is just a pair of scissors, and this is a piece of a drinking straw. So the first thing that I'm going to do is I'm going to cut the balloon so that I can stretch it over the mouth of the mason jar. So let me set the mason jar up like this and show you guys this cutting process. So here are my scissors, here's my balloon, and I'm just going to cut off the neck of the balloon like so. Okay, I don't need the scissors anymore, so I'm going to move them over there, and this little piece of neck, I can discard that as well. So now I've got the mason jar, and I've got my piece of balloon here, and I'm going to stretch the balloon over the mouth of the mason jar. Pretty good. It's like a little drum, actually. Okay, as you do this, you might find that some wrinkles perhaps form on this surface. So if that happens, just stretch the rubber band a little bit more to get rid of any of those little wrinkles. I did a good job the first time, so I don't have any wrinkles. And then to hold that membrane, that balloon in place, I'm just going to take a rubber band and I'm going to stretch it again around the mouth of the mason jar, just to give some extra hold to hold that balloon in place. Okay, so now you can see here I've got my balloon stretched over the mouth of the mason jar, and then I got my rubber band just to hold the balloon in place a little bit more firmly. And what I've essentially done is created a reservoir of air at whatever the barometric pressure happens to be at this particular moment. That's the pressure of air now trapped inside this vessel. And what will happen as the outside atmospheric pressure changes, it will cause this membrane here, if the barometric pressure goes up relative to the pressure in this jar, it'll deform the membrane downwards. And if the barometric pressure goes down with respect to the pressure of the air in this jar, it will deform the membrane upwards. And we're actually going to use that motion of this membrane as the ambient pressure changes as the way the instrument that we use to measure the pressure. So I'm going to put this just here almost out of view for a moment. We're going to create a pointer out of a piece of soda straw. And so the trick here is to use those scissors that I had before. I'll bring them back into view here. There are my sharp scissors to turn this drinking straw into a pointer. So I'm going to crush one of the edges here, And it's important as you make this cut in the drinking straw that you try to make as sharp a point as possible, because that point is actually going to be the pointer for our instrument. So I'm going to now turn these this way. I'm going to cut a little pointer out here, like so. And again, the sharper the better. So here comes my cut. Okay, so now you can see, let me pop this open. There we go. So I've turned my drinking straw essentially into a very sharp pointer there with a little tip on it. And now what I'm going to do, bring my mason jar back into view. I'm going to use my hot glue gun, and I'm going to just put a little dab of glue on the straw, and I'm going to affix the straw right to the center of this membrane. That's the spot where the motion is going to be the largest in responses to changes in atmospheric pressure. So I want the straw essentially to be pulled downwards as the pressure goes up, and I want it to be pushed upwards as the pressure goes down, and I'm going to use those motions to detect the change in pressure. So let me turn this over. Let me put just a little dab of glue here. I don't need a lot, just enough for it to stick without popping the balloon. Okay, and then we move the glue gun out of the way and turn this over and put this straw, push it right there. Into the center of the balloon. Okay, and now I'm all set. I actually have my device, and now all I have to do is set up the way that it takes measurement. So let me tip this on its side here so that you can see it and bring the pointer into view. So again, I've got the balloon, which changes shape in response to barometric pressure, and I've got the pointer, which is my drinking straw, fixed to the center of the balloon. So as the barometric pressure goes up, this membrane deforms, and as you can see, the pointer goes up. And as the barometric pressure drops, the membrane will expand, and see how it expands there, and the pointer will go down as the membrane's expanding. So that's essentially how this works. We now need to pair this component with the rain gauge so you can see how things measure. So that will happen in the next frame. Hold on for a sec. Okay, so here we are just in a slightly different frame of view. I brought back into the video our rain gauge that we built in the previous video. Remember, the rain gauge is affixed to this solid wood surface. It's glued on there, and that's so that when we sit it outside, it doesn't tip over if, say, a gust of wind blows. But the other attribute of the rain gauge was that we used this ruler, and we intentionally made the ruler longer than it needed to be. Remember that we can only measure rain up until we run out of ruler here, so it doesn't really make sense to have more than, say, 4 inches of ruler in the jar. But I told you in that video, and I'll remind you again here, that the rain gauge actually serves a double purpose, and now we will see what that double purpose is. So here's the piece of wood that the rain gauge is glued upon, and I've just grabbed another piece of wood out of my my scrap pile, which is right here. And the purpose of the second piece of wood is to serve just as a pedestal for my barometer, which here's the barometer instrument that we made in the previous framed video. And all I'm going to do, I can either glue or nail or maybe even screw this second piece of wood to the first piece of wood where my rain gauge is sitting. And once those two pieces of wood are attached together, I can just take my barometer and I can sit it right up on top. And what I'm going to do here is move the barometer so that the needle, the pointer, is right next to the scale on the rain gauge. Obviously this rain gauge isn't going to fill up to that level because the water will run over by that point. So I'm going to just use that extra run of ruler to my advantage in using the barometer as an instrument. So I'm going to slide this closer to us now and show you how this works. So right now, the barometer is reading about 17 centimeters. Now, remember, we read the rain using the inches scale, and I'm going to use the centimeter scale on the ruler to read the barometer. Now, this, even though it is a quantitative value, 17 centimeters, it doesn't physically correspond to anything of meaning. Pressure is measured in pascals or force per unit area. So all that we're doing is just looking at the deformation of this membrane and quantifying the deformation of this membrane and using that as a gauge to determine what the pressure actually is. So what we're going to look for is maybe on an hour-by-hour basis. We'll put together a log and see what the barometric pressure is doing as a function of time. So remember, right now, the pointer is sitting right at about 17 centimeters. And if the barometric pressure over the next hour were to increase, remember this membrane is going to deform inwards and the gauge is going to go up, which corresponds to about 16 inches, at least in this example. And if the opposite is true and the barometric pressure drops, then the gauge, there we go, is going to point downwards, say about 18 centimeters. So what we want to do is just keep a log, say on an hour-by-hour basis over the span of a day, as to what the barometric pressure is doing, what we're seeing here in terms of the gauge moving upwards or downwards, remembering that this scale is essentially reversed. So if we see the barometric pressure indicate from 17 to 16, even though that's a reduction on my scale, the scale again doesn't have any physical meaning, that reduction means that the barometric pressure increased because it caused the pointer to go upwards. And if we see an increase here from say 17 to 18 centimeters, that means that the barometric pressure actually decreased and the membrane went upwards, causing the pointer to go down. So that's essentially how to interpret that. So now we have two of our instruments. We have the rain gauge and we have a barometer. So please come back again and check out our next video. There will be a total of 4 of them on how to make these simple weather instruments using stuff you can find around the house. Once again, my name is Dr. Matthew J. Trom. I am from Engineer Inc. and from the Bellevue Bell Garden Bellevue Edible Learning Laboratory, and thank you for your attention.